this example, we're going to look at the following function: x squared plus y squared minus 4x plus 5y minus 8 is equal to 0. Now, say we wanted to calculate dy by dx. If we tried to do this in the usual way, it would be tricky, because we would have to rearrange the equation so that we have y written explicitly in terms of x, i.e. we would have y equals some function of x. It's not immediately clear how we would do that from this expression. So, we need a different method for a problem like this, and that method is called implicit differentiation. Let's consider the following example to illustrate the principle. If we have some function, z is y squared, where y is a function of x, but we don't know what the function is explicitly, then what if we wanted to calculate dz by dx? Well, by the chain rule, this is equal to dz by dy times dy by dx, which is equal to 2y times dy by dx. So, we've managed to differentiate y squared with respect to x. We differentiate the y squared part using the usual power rule, and then we multiply it by the derivative of y with respect to x, which we just leave written as dy by dx, since we don't know what this derivative is. Could we apply this technique to the function at the top? Well, we start by differentiating the expression with respect to x, just as we did here. We'll simply do this term by term. On the left hand side, this gives us d by dx of x squared plus d by dx of y squared minus 4d by dx of x plus 5d by dx of y. And on the right hand side, we still just have 0, since d by dx of 0 is 0. So, we can begin to evaluate this expression, but we must remember that whenever we differentiate a function of y with respect to x, we must use the chain rule. First, we'll differentiate the function with respect to y, and then times this by dy by dx, since we are considering y to be a function of x. So, we get 2x plus, now we start to use the chain rule, d by dy of y squared times dy by dx minus 4 times, well, d by dx of x is just 1, plus 5 times, again another use of the chain rule, d by dy of y times dy by dx is equal to 0. So now we can go a little bit further and say that 2x plus 2y times dy by dx minus 4 plus 5 times dy by dx, remember that d by dy of y is just 1, is equal to 0. So 2x minus 4 plus dy by dx times 2y plus 5 is equal to 0. Here, we've just rearranged the left hand side and factored the dy by dx out. So we can rearrange now and say that dy by dx is 4 minus 2x divided by 2y plus 5. And this is as far as we can go, because we don't know explicitly what y is in terms of x. That's why this method is called implicit differentiation.